little bit here, and as you can see here, right? So we will explain here and you will understand. Okay, so what approaches we have here, right? Oh, sorry. So let's understand the approach, right? Not here, let's make it in center. Okay, here. So if we have approach here, right, we will talk about the approach, right? How many approaches we have, right? So first we can go through with what brute force, right? Brute force. We can go with the brute force approach. And so first I'll go with the brute force approach and then we will understand, right? So in this brute force approach, we can take all possible steps combinations, that is one or two, right? We can go to one step or in two steps, either one step or two step, right? So at every steps we are calling the function climb stairs. So we will take what? Climb stairs, a function, right? What we can do, we can take a climb stair name, climb stairs. This will be the function. Okay, for what? For two steps, right? Either we will go step one or either we will go what? Two step, right? You know, and we will return the sum of returned value of both function, right? What we will do, we will return with the sum of return value of both function, either this one or either this one. How we will do that? So if this is the staircase is a function, climb staircase, so how we will do that? We'll do climb stairs, right? Climb stairs. First we will take I, then we will take n, right? So what we will do, say that I plus 1 in one step, right? This is for the one step, and then we will climb what? Climb a stair for what? I plus 2 comma n, right? We will, so sorry, we have not written here climb stair, so you can write here climb a stair. Okay, so first is I plus 1 and second is what? I plus 2 and hyphen n, and both combination will return, if we will do the sum, it will return what? This one, correct? Climb stair I comma n. Okay, so what will happen here? We will go through what? We will write here, if we'll let's go and write some code, then we will understand. Okay, let me zoom a little bit here. Okay, so if we will talk about here for this function, right, public int, right, public int climb stairs, right? This was the function, right? So we will return what? We will return climb stairs, right? Climb stairs, and we will pass what? 0 hyphen comma n, correct? 0 comma n, because this is our function. We will start from what? 0 index, right? Then we have to write the function, right? So this is not the same function, right? We have to make it different, and for that we can do like this, and this will our function that will calculate what? So both steps, number of steps it will call. Let's see, public int, then we'll pass this function. So at the place of I 0, what we will do, I, correct, and the plus of this it will remain same. We can take it remain same. So if I is what, greater than n, we will return 0, correct. If I is greater than n, means what, we will return 0. We do not have to climb, climbing is not required. So if I is equal to n, means what, return 1, correct. Only one step you can do. If you are at the top, so you can maximum move by one step only, right. Now if return the climb stairs, this function, and that is I plus 1 for the one step, right, and the second step is what, give me 1 minute so that glitch, yeah, and then if we'll write here climb stairs, right, what, I plus 2, correct, for the 2 steps, and this function will return what, sum, right, this is the sum, final sum, and you will reach here at here, value will return here, correct. And so that if we'll talk about complexity, if we'll talk about here complexity, okay, so time complexity is what, we will talk about time complexity, right, means what, this should be, we are moving one step and 2 step, either one step 2 step, right. So the size of recursion is what, to the power n, right, because we are checking for all the steps, right, for one step and 2 step both, right, and that's why it is O of to the power n. Let's understand why it is this, okay. So if we have a recursion, tree, right, if we have recursion tree for what, n equal to 5, so we will start from what, 0, 5, correct. This will be what happened, 1, 5, either we will one step, or either we will go to 2 step, correct, either we will move to 1 step or 2 step, correct. Next will what happen, similarly it will move to what, 2 step, by we are moving one by one step, right, so 2, 3, and here 3, 5, correct. Similarly we will reach what, 3, 5, it will reach what, 4, 5, because these are for 2 steps, right. And similarly if we will move like this here, what will happen, this will stop here, right, we will in the next step, what happened, we will reach here 4 and 5, correct. And here what happened, 5, 5, right, here what happened, 6, 5, so this is end, right. And if we'll talk about for this one, what will happen, we will go for this one, 5, 5, correct, one step, and this is what, 6, 5, correct. We will move like this, okay. So total, if this is n equal to 5, it was n equal to 5, and so total number of node is what? If we'll count here, total number of is what? 2 to the power n, right? If we have means 2 to the power 5, right? And it will be what? 2 into 2 into 2 into 2 into 2, 4 8 4 8 8 8 8 into 2, 16 16 to 2, 32. So total 32 node will be here, right? So the time complexity will be what? This one, O to the power n. But space complexity will remain same, O of n. This is your space complexity, okay? Because the depth of the recursion tree can go up to what? Go up to what? Maximum n. N is what? 5. Now this is our approach, okay? In the next part of this video we will see recursion with memorization. Thank you guys. Please let me know if you have any doubt.